Hello and welcome back. In the previous video, we started with an introduction to MATLAB programming. We went over the fundamentals of high-level programming languages, defined as any programming language with a level of abstraction higher than assembly. And we mentioned that some of the common elements of programming languages were that in all of them, when you are learning, you have to see, well, how do you define the variables? What are the data types? What are the data structures? And that was the topic in the last video. The next item was, well, how do you do input and output? Effectively, how do you get input from the keyboard, a file, or a device, or output to the screen, file, or device? Next element, mathematical and logical operations, conditional execution, if-else statements, repetition or iteration. Those are all about program flow control. Functional programming, object-oriented programming. You need to look at also what are the specialized libraries that you have, like in the case of MATLAB. There is, even in the MATLAB core, a lot of libraries to do scientific and engineering computation, as well as then you have a specialized library. In MATLAB, we call those toolboxes, or in Octave, we call those packages, as well as perhaps how to create graphical user interfaces. So in the last video, we went over the first part, variables. And in this video, we're going to go over the next element, input and output. So if you recall, if we create the scripts like this by defining the cells, we can not only run them, but we can also publish them. So we can create a published version of the script where each one of these elements with each cell with a double percentage sign becomes clickable. So the common elements. You have then the comments, and then you have the code, and you have the output also. So the next part is, of course, input and output. So let's go over input and output. Number one, what do we mean by this? Well, input. How do we get input? Input from keyboard. You can get it also directly from a file or from a device. You may have a data acquisition card or something like that. Or, and output to screen, file, or device. We are controlling a device. So that's a comment. Key concepts that we're going to go over. So let's create an item like this. So a function or key functions and concepts. So input is an important function. Display printf. We should go also format. Load. Associated with this, I'm going to go with fopen and fclose. Load. I think that's it. So let's go over these functions so that you learn the fundamentals of input and output in MATLAB and Octave. Let's start with the basic input. The most basic way to get an input, of course, from the keyboard to a variable is what we did before. You use the assignment operator, a equals 5, and there you got it. You have a. And so let's now prompt the user. We could say, okay, x equals input, and now we are using the function input. Let's look at a help input. Prompt the user input. Okay, so you can see here, it prompts the user on the screen, waits for the input from the keyboard, and evaluates the expression from the input, and then returns the result. And here you have an example, reply input. Do you want more? Yes or no? And then you have a string. Okay, so let's use it. Input, and say enter. By the way, when you enter a function in this version of MATLAB, like input, if you stop, right, it's going to give you online help, as you can see there, and you can click more help in order to get effectively the same help that you got there in the command window, okay? With some examples and such. It's actually more extensive, this online help. Okay, so let's keep going. Input. A string is in quotes. Let's do something like enter the value of x, y, and let's store it in the variable x. The input here is enter the value of y, space. Now we're going to do an operation, c equals to x plus y. So let's run this section of the code. Run selection. I'm doing only this cell. Actually, I'm going to CLC and clear all the variables. Notice that the workspace is going to get cleared. So this is what I'm running in the selection. Enter the value of x, 5. Enter the value of y, 4.5. And it gives me the result right there. Right? Now, the simplest way of doing output to the screen is actually including the variable name without the semicolon. The semicolon tells you do not provide the output. Let's do this again. Variable. Notice that you have the variables here in the workspace. This is useful for debugging. Now, since they are variables, the value can change. So I'm going to say in this case 6, 4.2 or 4.5. And notice it has been evaluated, the sum of those, but it has not been prompted to the output. Now if I type C with a semicolon, it's not prompted. If I type C with a semicolon, it's prompted. So that is the simplest output to the screen. Okay, let's go ahead and do something more elaborate to the output. Incidentally, about input and output and this prompting. Sometimes when students learn that you can do this input and output, you start doing a lot of prompting. Now, for advanced programmers, this prompting becomes very annoying. You will see that it's better to just include these things if you're creating a function as input variables, as opposed to enter this, enter that. Imagine that this piece of code needs to be put or needs to be executed many times. All this prompting to the user becomes very annoying. Okay, so this prompting can be overused, so be careful with over prompting the user. In something like this, if we were to create a function to add numbers, it would be better that add numbers and then you have the variables that you're going to input, as opposed to this prompting. Now, that also is the case when you want to include a piece of code into some other piece of code that is repeated many times, like in a for loop. You don't want a prompt every single time. Okay? So, nevertheless, there are situations where you want to do this. And let's do that the simplest, so simple output, simple screen output. So if input is the simple prompt to the screen and getting input from the screen, input from a screen, to get a screen output, we can use the function display. So help disp. What you can see here is that displays the array X without printing the array name or the additional description. And so let's go with this. So let's do something like this. And actually, let's do the sum of the variables is, and then I'm going to actually just say C. Imagine that we did something like this, right? Okay. Let's run selection. 5, 7.6. The sum of the variables is, and then I type C. What happens if I wanted to have the C embedded in the disk? It can be done, although this is typically just to put a string at the output. And so it takes a string as the input to this function. Now we could have done something like this, and in brackets, I'm going to pick my string, and then I'm going to convert the C from a number to a string. Anytime that you encounter a new function, make sure that you look at the help. It says, okay, converts the value x, which can be a matrix, into its character equivalent representation. Okay? So notice if I have C, I do whose, tells me C is a double, 1 by 1. If I do C2 equals num to a string of C, now I got a character type, notice here. And so while I can do C plus 2, C2 plus 2 does not make sense. This is a common bug. C now, C2 is a character value. Do not confuse this with a number. Notice that this is not what you expected. So anyway, I do the number to string of C. All this is concatenated in the part of the same string array. And this should work. Let's see. Value of x, 5, value of y, 7.5. The sum of the variables is done. So anyway, that's the way it will be done. Here is by just doing a string and then actually just naming the variable without a semicolon, and over here is outputting it. Okay, next. So let's do a more complex output to screen or file. You can do this with the function printf, help f printf. Now, this is much more versatile. It's similar to what you have in C, if you're familiar with C. And so let's do an example here. Same thing, printf, the sum of the variable, the sum of the is, okay, so now I can say, well, I'm going to include, okay, this is going to be a number, and you have to indicate whether it is floating, whether it's a string. G is a floating, but with the minimum precision that you need. I'll show you the difference. Just like the sum of the numbers is this. Then I actually, let me do here another one like name, input, enter your name, and I'm going to indicate that this is a string. And so I'm going to do that, and then the sum of the variables is this, and then I'm saying this is a string, and then I put the variables, right? So this is my string, and associated with this percentage G is going to be my C, and associated with the percent S for string will be name that we captured here. So let's run this selection. 5, 8.5. This part so far is here, line 129, 120 and 129. Enter your name. Oh, sorry. Oh, it's giving it back because I didn't put the semicolon. So I'm going to say Matteo. Notice that there's no space because I didn't include the space there. Let's fix that. And now it tells me there. Okay. So let's make this semicolon so it doesn't print this out after entering it, the value that we enter. And all this over here, we're going to say semicolon and a space. And over here, notice that it says Matteo and the prompt just came. Let's create a new line, -n. This is all in the documentation. Notice, new line. And let's run it. Incidentally, when you say run selection, you are running that particular cell defined with a double percentage. If you do run all, it will run the entire script. Okay? So let's go over this. And actually, let me just do this and run it again. CLC. And clear all. Okay. Run selection. Enter the value of x, 5. And this is going to create the variable x that we are going to see in the workspace. Variable y, 5.6. Name Matteo. Notice Matteo, 5.6. The sum of the variables is 10.6. The sum of the variables is 10.6 Matteo. This is a more powerful. Then have to convert the number to string. And we could define in the middle of the string that this was going to be a number and then add a string there. Now, if I enter this with an F, it will do it in floating point. So you see more significant digits. If I do a V, that will be a decimal place. I mean, an integer. If we do it like I did it with G, incidentally, if you right click, you can say help f printf, and you get a little bit more help. And so let's go over this a little bit more in detail. Very good examples here. Like in this example, you have x is, and then you have, oh, this is a floating, but I want in total 4 digits with 2 significant digits. And so it shows you how this is gonna format it. Double precision values. You wanna do something in tabular form. How to do it to a file directly. So here you have the example of the operator. The identifier, the flags, fields, the precision, how many precision do you have, field width. And here %f is a fixed point notation. I was using G before, which is quite useful, more contact than E or F, okay? No trailing zeros. And S is for characters. And here you have some examples. It's worthwhile to see it. Okay? Also, I'm using the new line here. So with that, There you go. Okay, and so this is, we went over input, displays, fprintf. If we wanted to write this to a file, there are some other functions, fopen and fclose, that are important to know. So, fopen, this is to open a file. And you can say, well, if it doesn't exist, to create it, whether you are writing it for reading or you are open it for writing. And so let's do here an example where I'm going to open, so output to screen. Output to file. And by the way, this is more powerful. Than display. Output to a file. So the first thing, we need to open that file. And you can do that with fopen. Now, fopen. Let's create a file. Perhaps we can do something like example or my results. Okay, let's imagine that this was something, and I'm going to do a txt. And it's going to be for writing. Let's open this with write permissions. If it doesn't exist, it creates it. And the FID is the identifier of the file, so then we could do fprintf and effectively the same formatting, but instead of saying the output goes to the screen, if we type FID, it will go to that file. And then we can close it. Fclose FID, the file. Okay, let's go. So let's do this part of the code. If we enter this, we open the file my results. If it doesn't exist, we create it. And then what we were prompting to the screen before, we simply send to that file. Oh, and because we cleared everything, we actually need to run 5, 6.2, Mateo. Did this. Notice this answer 0. That tells you that actually close the file successfully. If you type help fclose, you will realize, you will see that if it is done successfully, the output is a 0. If it is unsuccessfully, it will be a -1. As you can see here, fclose returns a 0 if successful or a -1 if it is not. Of course, the reason why that happened is because we didn't enter a semicolon or a semicolon. Otherwise, so fclose FID. Now in this case, it didn't work because it was already closed. If we open it, then we can close it. And it provides the 0 because it was able to do it. So that means that if we go to this directory that we have in this path, we should be able to see my results with these results. Let's do it. My results. Oh, nothing was written. So what's going on? Let's do it again. Let's see. Needed a WT because the file didn't exist. So let's go ahead and run this part of the code. The variables are defined, as you can see, x, y, and z. The variable c was 11.2. The variable name is Mateo, so we should see a file named myresults.txt, and inside the file you should have the sum of the variables is 11.2 Mateo. So let's run it, and let's see if that's the case. So my results was created, and we open it. There we have the variable. The sum of the variables is 11.2 Mateo. So we went over input, prompting the user with input, output, simple to the screen display, more complex to the screen, fprintf, much more powerful, or to a file. Let me go over format. That's the format to the screen. So there's different ways that you can format, like format short. It formats the output of 15 digits long, 5 digits long, 15 digits. There is short E, etc. So let me give you an example here. So we have C. So format long, if I type C, this is what you see. Format short, this is C. Format bank will be like you will see it in bank format, etc. Okay, so format short, format long, format bank, there are others. Format short E, exponential notation. You're going to put it format short. So that's I included here in the input output, since that gives you output to the screen the way it's formatted. Okay, let's load data from a file. Incidentally, over here we went over fopen, help fopen, and then fclose. There are other important functions, fscans, etc. that are check them out. To do low-level controls to open a file and for read access, and then create a string containing the name of the file that is open. Sorry, let me go here. F. This is what I wanted to show. So this is to read the data from a file with a low-level control. There are others. Now I'm going to show here read data from file that is either a MATLAB type of file like an MAT, or comma delimited, or something that is already formatted right. And you could use the command load, help load. This is the simplest way to load data, is load and then the file name, that's the function, and you can load particular variables only. And here you have an example, right? So you can either do it load. So let me load, for instance, handle. That is a file that you have with MATLAB. This one. And you can either do it like this or in function form. So I'm going to load handle. Load. Actually, let me clear all the variables. Clear all. Load handle. It loads two variables, y and f of s. Later I will go in plotting when I'm covering specific built-in functions that MATLAB has, But for now, let me just plot y. This is a clip of Handel's Hallelujah. And this is a plot of the time domain waveform. Okay. Another function that you can have to play it is sound, y, but incidentally, f of x is a sampling frequency. This was sampled at 8,192 hertz. That means samples per second. Y, of course, is the variable. You can see when you say size of y, or if you say whose, that this is a double, and it is a column vector. You see, you have all these rows, 73,113 by 1. And you could play it with sound. We'll go over these things later when we go over built-in functions. Y with fs. You also do normalize. So you say help sound sc. It auto scales it. So let's do this sc. At this point, though, the only thing I wanted to show is that in MATLAB, you can use the function load to load data from a file, and the function save to save data to a file. And when you use save, you say, well, how do you want to save it? Is it in ASCII format? It can be MAT format, and you put the file name and the variable. So over here, let's consider that we run our full script, save. I'm going to say, well, save, let me create a file name, my data. And here we have an example. Right? Save my data. And now I type the variables. I want x, y, and z. Let's run it. X, comma, y, comma, z. Variable of x, value of x 5, y 7.5, name Matteo. I have an error here, and that's because it requires strings, the variable names as strings. So let's do this, and it should be fine. Now it works. Okay, so if we type, let me clear all the variables, clear all. To use ls, that's the Unix command for listing what you have in that directory, which is what you have in the current folder here. Notice that now we created a my data MAT. And if we use load my data, what's going to do, look at the workspace here, we don't have anything in the workspace, it will load those variables to the workspace, X, Y, and Z. Now you could save the data in ASCII format, you could save it in all the, you wanna, let's type help save and let's look at all the ways you can save it, or otherwise, if you want more documentation, just highlight save, right click, or control click in Mac, help save, and here you have, and now in the syntax, For each one of them, you can have an example. So I was using this one, right? File name and variables. Example is what you have here. So notice P is a random number, Q is ones, says both of them right there. Here's an example where you're doing it with an ASCII format. Okay. Now, with fprintf, you can also save data to a file with more control. But in many cases, when you want to just save your workspace variables or something that you have created in a particular file format, save is very useful as well as load. So with that, you recall what we are doing is going over the common elements of high-level programming languages. In the previous video, we went over variables, data types, and data structures at a high level. In this one, we went over input and output, how to get data from the keyboard, a file, or device. We'll see the device in some other video. Output to the screen, file or device. We saw to the screen and to a file. In the next video, we're going to go over mathematical and logical operators. Now, over here, just remember what are some of the key functions that you should keep in mind. Input, display, fprintf, fopen and fclose, format, load, and save. Now, incidentally, remember, this prompting the user with this input can be very annoying. So it is okay to use it when that's the design for the program, but typically it is much better to create functions where the user can already input the variables or get the variables from somewhere else in the program and not slowing down. This is like a speed bump. Let's go ahead and publish, and you're going to see that one of the effects of this when you publish is that you're using input. Now you have a problem right here. So what I'm going to do is ending up commenting this input, and instead I'm just going to define here some variables. X equals 5, Y equals 6.6, name equals Mateo, so that we can still publish and have this as a reference. Let's see if it works. There you go. So we have the common elements variables input output and an undefined variable n. Here is the error. Notice that when we did the publish, it gave us the line number, and so you can see, oh, and we put the comment the wrong place. So let's do it again. Input and output. Here you go. Everything worked. Thank you. As I mentioned, in the next video in the series, we will go over mathematical and logical operators. Thanks.